Hello, my name is Michael Findeis and I am the President of the IACDS. On behalf of the Association, we would like to thank all the attendees for your time and participation, hoping that the webinar will be useful. I would also like to thank the speakers for the time and dedication. Please note that during the session, only the speakers will be able to activate their camera and microphone. As attendees, you can participate and ask your question via chat. All IACDS sessions will be recorded for later editing and online publication. Before giving way to the speakers, I would like to introduce IACDS in case any of you do not know us. The International Association of Concrete Drillers and Sawers, IACDS, is the organization representing the associations, companies and professionals of the concrete drilling sawing industry around the globe. The association has a strong focus on providing an international union with the cooperation of trade and associations. IACDS brings together the industry expert on a regular basis, meeting and working together on the common goals since 1999. IACDS is the platform that brings together the key actors of the trade and represents internationally the national concrete drilling and sawing associations and specialized contractors and suppliers. IACDS works actively to promote the interests of the concrete drilling and sawing industry and exchange information on techniques, working methods and training. For this purpose, the association prepares many initiatives to share industry knowledge with stakeholders and other entities linked to this trade. This is the case of publications as the yearbook and other guides that promote concrete cutting and sawing activities. Since the beginnings of the association, IACDS organizes every year a few activities and events to bring together the industry and support its national associations in their own activities, conventions, meetings, workshops, trade fairs, etc. In addition to representing and looking after the interests of companies of the concrete cutting and sawing industry, IACDS has an important role in the dissemination of this activity. To achieve these objectives, IACDS promotes different initiatives to teach and demonstrate what can be done with the techniques and products used for cutting and sawing. Among these initiatives, the most notable is the Diamond Award. The Diamond Award is an international competition which is organized every 3 years for the concrete sawing and drilling industry to improve the visibility of the companies through their jobs as well as to demonstrate the professionalism. It has two categories, jobs and products, to showcase the expertise of the contractors and the innovation of manufacturers. IACDS gives importance to this dissemination of the activities and services developed by IACDS members by implementing a series of educational initiatives. For instance, webinars are short and educational sessions, about 1 hour, hosted online and broadcast live. The webinars will be given in English. All the webinars are being recorded to be published later on the private area of the IACDS website, available for members and subscribers. IACDS also works on audiovisual contents available in the IACDS YouTube channel. Here you can find videos about the industry, IACDS events, and interviews to our members. All these contents and many more are available in the IACDS website for those who have a membership or a subscription. You can check out the subscription models in www.iacds.org/private. If your activity is related to concrete sawing and drilling and you are interested in learning more about this industry, growing your business and sharing experiences with the most relevant companies and associations worldwide, you can contact us and we will be happy to help you. If you need more information, please do not hesitate to contact us through the contact information on the screen. Thanks again, and we hope you enjoy the webinar.
Hello, good afternoon, good morning if you're watching us from the US. My name is Jose Blanco, and I'm the Secretary General for the IACDS. So without going any further, I would like to ask my colleague, Erin O'Brien. She's the General Manager for the CSDA, the American Concrete Sawing and Drilling Association, to turn on the camera and microphone and to start the session. Hello, Erin, and welcome. Good morning to you.
Good morning. Thank you so much, Jose. Thanks for having me. So as Jose said, my name's Erin O'Brien. I'm the Executive Director for CSDA, Concrete Sawing and Drilling Association. And I also served as the Technical Coordinator for our the IACDS brand new Slurry Management document that's going to be released here hopefully in just a few weeks in the month of March. So this webinar is kind of serving as a guide towards that. The presenter, Ryan Klacking, with SLURRYMONSTER, who is a CSDA member, was one of the participants in the creation of this document, as were several other manufacturer contractor members from not just CSDA, but all over the world. So we appreciate everyone's time and efforts into getting this document published, and we're looking forward to sharing it with you. If you're not familiar with CSDA, we are the US-based association for concrete sawing and drilling in North America, but we do have international membership. So many IACDS members are also CSDA members, and we do a lot of cross-promotion, coordination, not just of documents, but also of events, and are active participants in each other's activities. So we are excited to host our upcoming convention. We're going to be live and in person for the first time in actually about 3 years. So we're looking forward to that. No, it's going to be difficult for many of you to join us, but if you are able, we are meeting in Scottsdale, Arizona at the end of March 28th through April 1st next month, and very much looking forward to that program. In addition, we just got back from the World of Concrete show, which was in Las Vegas last month. Again, very excited to be meeting in person again. And we do hope to see all of you at the World of Concrete next year, or perhaps at a show in Europe, possibly Bauma this fall. If you have any questions about CSDA, we also publish several documents, technical documents, again, many in conjunction with IACDS, but we do have some of our own that are targeted a little bit more towards North America. But all those are available on our website, csda.org, as are many other resources. And if you have any questions, also please feel free to reach out and contact me. I'll go ahead and let Ryan take over and kick off the webinar.
My name is Ryan Klacking. I'm the president of SLURRYMONSTER. Here at SLURRYMONSTER, we manufacture several products, equipment, and provide services in the realm of concrete slurry management. And today I'd like to thank the IACDS and CSDA for including us in this presentation. And today I just want to go through the focus of the presentation today will be the characteristics of concrete slurry and the testing types that could be offered. A summary of the presentation will include introducing wet versus dry cutting, talking about the types of cutting, drilling, cutting, grinding applications in construction, going through the pros and the cons of dry versus wet cutting, reviewing the characteristics of concrete slurry themselves, job site management techniques to combat concrete slurry. We'll go through different concrete slurry processing applications, and then the importance of testing concrete slurry and creating waste profiles. So the first I'd like to start with is dry versus wet. This might be a little elementary to some people on the call, but I figured I would just kind of go through, how this started and how we're ending up wet cutting versus dry cutting. But, what is dry cutting essentially? It's cutting concrete without an anti-dusting agent such as water. In this presentation, what is wet cutting? We'll simplify it to a method of cutting concrete using an anti-dusting agent such as water. A lot of people in the field, there's several different types of methods for cutting concrete. We won't go through them all, but some of them include saw cutting, window cutting, which essentially is picture framing so that you can do slab removal replacement, typically silica dust and wet cutting exposed there. Joint cutting, wall sawing. Grind and polishing has really taken off in the past 10 to 15 years for aesthetics, for new commercial industrial flooring. some of the coring and drilling activities and grooving. Saw cutting, typically what is saw cutting? Saw cutting is the act of creating joints or breaks in the slab using a mechanical tool with either a diamond or abrasive blades. They range in various size, very hard to encapsulate dry based off the larger machines. Window cutting, we see a lot of this in the US at least, removing and replacing floors or doing large floor surface repairs. A lot of people are actually starting to do joint cutting wet as well for control joints. And, wall sawing and different type of applications for introducing, new dock doors and things of that nature. These are all producing either dust or slurry. Concrete grinding and polishing. So I'm sure across the world in the United States, this has really grown from commercial to retail to industrial markets. But there's various types, grinding and polishing is the act of using highly abrasive pads to produce a concrete finish on a concrete floor, essentially resulting in an aesthetic look. This can be performed dry or wet. A lot of new applications are calling for faster schedules, higher production, and we're typically seeing these applications performed wet. The machines include either walk behind or rider grinders. There's some pictures here to the left of, very large industrial equipment, moving on to the right to smaller into the smallest of walk behinds. But both we see a consistency of dry and wet applications, mostly dry on smaller projects and mostly all wet on larger projects. Concrete coring and drilling operations produce slurry or dust. Concrete coring and drilling is the process of removing a cylinder from the rest of the concrete slab, usually by a core drill. We see a lot of these applications in construction used to create openings for plumbing and electrical cables, HVAC equipment, or just to analyze the state of existing concrete to provide analysis on repairs or remediation. Other applications covered in these associations, concrete grooving. Most of the time we see this in the outdoor application through roads to provide, anti-stick properties, but concrete grooving is the act of, grinding shallow grooves into the surface of a road and concrete structure. Concrete grooves improve the traction and grip on the road surface and can be used as a way to rehabilitate failing or old sections of road. We don't do a lot of overlays here in the United States, but I am aware that they do a lot of overlay work in other countries, and you'll also see these applications produced there. A lot of these applications are done wet or dry, depending on the manufacturer of the equipment, and there's processes for managing both types. I'd like to do a brief overview of dry and wet cutting just to cover our lead into the properties of concrete slurry. But dry cutting concrete, I'd like to discuss the pros and cons. So dry cutting doesn't require any water delivery system, which therefore you don't have all the logistics to worry about water delivery and how you're going to feed your machines and keep dust down. There's less mess, no need to worry about the concrete slurry mess or cleanup after. Typically it's done with dust collectors. There seems to be less chance for electrical hazards if you're using electrical equipment. Therefore, the cords aren't laying in the slurry during the construction application. The cons of dry cutting is it creates a large volume of hazardous respirable crystalline dust silica, which is regulated here in the United States. I'm not exactly sure the other regulations across the world, but this is highly regulated and considered to be hazardous. So there's a need for additional PPE on site to prepare for full encapsulation, dust shrouds, etc. And also dry cutting makes blades and things overheat, causing extra downtime and more wear on the equipment. Hazards of dry cutting are regulated here in the United States. Again, I'm not sure about regulations abroad, but OSHA actually regulates and it's mandated that there's a silica dust procedure and plan. Every construction company on site has to have a written and drafted OSHA silica plan for that project. Anybody that's actually taking part in the services that would create dust all have to have written exposure plans, and the employees themselves have to have proof that they've been trained and actually sign documents that they have been trained by their employer on these specifics. But basically, it requires a limit of 25 micrograms per meter of air. That's a very, very, very small amount in an 8-hour shift. Again, this is a very, very small amount of exposure that's allowed Table 1 within this standard pretty much goes through all the procedures and methods that are required and will help support to manage this standard. I'd like to go through dust containment methods for dry cutting. Again, table 1 is what would be referenced when dry cutting. It's going to go through what type of vacuums are essentially paired with various types of equipment to try to keep you in compliance, so that, you know, all those vacuums have to be 99.9% efficient HEPA with cleaning mechanisms. They have to be taken care of and working in optimal condition. Let's review a little bit of the wet cutting pros and cons. So pros and cons of wet cutting is it's easier to contrast dust silica, especially for very large machines where you're not able to completely shroud them due to their manufacturing restraints. But there's less PPE. Typically wet down, you're not going to have dust exposure as much as you would during dry, and it's much more easy to control. This has led to a reduction in fines of silica exposure violations. It also improves the performance of the blades and the equipment through lubrication and reducing those risks as overheating. The cons of wet cutting is the need to actually have set up watery delivery systems, and as well as different equipment for slurry remediation. And it can be messy and intrusive, and you know, you have to have a protection plan to make sure you're protecting all your customers' assets. One first step is the dust containment methods for wet cutting is how to properly reduce the silica exposure. A lot of this is directed by the manufacturer's example of, you know, feeding a saw at 5 gallons a minute, or various types of very specifics by the manufacturer allowing you to set your equipment up properly. But basically what you're trying to do is feed the machines enough to not have any dust whatsoever being released into the air. Some of the methods of obtaining water upsite can be direct feed from a water tap and ran to the specific machine, providing water trucks or water totes and pumps. As you can see on the right, there's a few options of those. Very importantly, so the characteristics of concrete slurry, this is really the focus of the presentation. So it takes a lot of research and development and understanding of many types of regulations and details to kind of come up with, you know, a solution. But basically, concrete slurry has a high pH. It can cause a lot of issues if not handled properly. What we see commonly is concrete slurry, even decanted or recycled water, is discharged into sewer systems. Truthfully, at least in the United States, this would require a discharge permit that has to be submitted for and received by the contractor prior to, you know, releasing even clean, free water into any sewer system. That's obviously for storm sewer, but there's also we have agencies like the POTWs, which is any publicly owned treatment works facility. That is also regulated. It could be higher and lower, but we see a national average of discharge allowable in a, you know, a private, that would be like your sanitary based sewer system, anywhere between 6.5 and 8.5, which concrete slurry typically has a pH in excess of 13. So due to that high pH, concrete left on the side of the road or in drainage ditches, we see quite often, especially in road grinding projects. That high pH slurry can cause chemical burns to animals. It can infiltrate and contaminate local aquifers, which can contaminate drinking water. It can enter sewer systems and cause long-lasting damage on aquatic life, rivers, streams, and lakes. I think we have some slides and there's other resources to kind of show even like aquatic life's ability to survive in different pH elements. So pH is a very specific thing when it comes to processing concrete slurry. Again, you're trying to get it in a neutralized state somewhere between 6 and 9, 6.5 to 8.5, at least here in the United States. You'd have to check with your local regulations, but this is highly regulated and for various types of reasons, and there should be a control procedure in place, or at least an understanding of knowing the regulations if there is or isn't. We do have certain areas like high industrialized cities, states. They might have higher limits because they're used to processing so much industrial waste, but others may have lower. So it's very important to check on what requirements could be honored there. One of the next characteristics of concrete slurry is the toxicity in metals. So toxic substances to humans can be found in concrete slurry through two main pathways. This is again driven from regulation, but you'd have to check with your local regulation and whatever sort of standards are set in each territory. But migration of materials in concrete. So what that really means is concrete's like a sponge. It's going to absorb anything it comes into contact with. So concrete being a porous material, it's going to allow any external substances to be absorbed and become trapped within that slab. So any substances could be absorbed in concrete, such as oil to formaldehyde, gasoline to Roundup, or asbestos can be trapped and not exposed until ground cut. So that creates a slight issue, especially if you're doing waste profiles with different types of concrete slabs or processes. New construction is a bit different, but renovations are, there's a lot of different industrial applications, manufacturing applications where there could be things or there could be substances introduced to the floor over time that could be hazardous. So it's always important to be aware of, what type of project you're entering and what type of toxicity could be possible from performing these applications. The substances here in the United States, the substances that can initially be found in concrete, there's a list of them, but the US EPA finds metals such as lead and cadmium to be toxic, which both of these metals are actually found in Portland cement themselves. So it doesn't necessarily have to be introduced, but there are metals that are toxic already in concrete that is regulated by the EPA, which then could provide some testing measures later. Another characteristic is the state of concrete slurry. So due to the necessity of the anti-dusting agent in order to reduce the dust exposure, concrete slurry is a semi-solid waste that exhibits properties of liquid. So anything that doesn't pass a paint filter test is actually considered to be a liquid. Landfills typically refuse to take any liquids due to the inability to create leachate or cause damage to the landfill. So basically, it's not that most landfills do not have wet processing facilities at a landfill site. It's very rare, at least here in the United States. That might be different in certain areas, but since they can't process wet concrete slurry, they refuse to take it. Therefore, the only way to get concrete slurry to a landfill would be through making sure it's solidified and able to pass certain tests. So that's basically the state. One thing that came up in the past few years, which is a characteristic of concrete slurry, we've been performing testing on is sulfur and sulfate. So sulfur and sulfate can occasionally be found in concrete and concrete slurry due to several reasons. So one of the reasons is the soil in contact with the slab containing high amounts of sulfate, and then actually using migration to actually penetrate the concrete slab. Therefore, if there was any application, you could potentially have sulfur in concrete. Oxidation of pyrite and clay formations near concrete can cause sulfur contaminated concrete. Bacterial activity in sewers. Therefore, if there's a sewer leak or breach, that could cause contamination of sulfur in concrete. And then seawater as well. So we'll go through a little bit later why sulfur is an issue, but sulfur can essentially be absorbed into concrete through various types of functions and should be considered. A lot of U.S. regulations, again, I'm speaking to the U.S., that's what we know. There's regulatory agencies across the world. It would take a lot of bandwidth to understand them all, but we're definitely learning here. So concrete slurry is considered to be a special waste because it contains toxins and it can be considered hazardous. So concrete slurry that is dry can also be agitated and stir up silica dust. What does that really mean? That means if concrete slurry was unprocessed laying in a corner and then laid to dry, if it was disturbed, whether it's indoors or outdoors, that could create respirable dust silica, which is then considered to be hazardous by OSHA, which then could create violations. So there are 4 elements of waste and a substance that can fall under the considered to be hazardous by the EPA. These 4 include ignitability, toxicity, reactivity, and corrosivity. There's actually very specific measures that a waste can have certain amounts in before it becomes hazardous, but those are the 4 characteristics that you're looking for. Special waste is defined by a landfill as anything that can be potentially hazardous. So concrete slurry is considered special waste because there's lots of things that could make it hazardous. Therefore, it's anything that could potentially be hazardous. And it may be required to be tested before disposed of. So typical testing includes reviewing the heavy metals, volatiles, semi-volatiles, corrosivity, sulfur, and various types of things. But it's always good to check your local regulations and see exactly what the requirements are from the landfill operator. So based off those characteristics, there's various job site management techniques that can be used for concrete slurry. So, there's, the first thing to do is create job site management plans and figuring out which location where the slurry management plan is going to be, whether it has to be mobile or stationary, meaning is it being moved throughout the project or can it be stationary and everything go through it? That's a big consideration. You always want to consider the terrain and slope for runoff. Therefore, if you have any breaches or you have any leaks or you have anything that's being, to water that it's not pointing to sort of any, sewer or drain or lake or river or anything that could access any of those. So things that need to be considered when managing the slurry is typically risk control, your water source, where you're going to find your water source. Is there any contaminants that you know of? Is, this a waste profile of an industrial application that you're using high amounts of oils or various things? And what is that waste profile? The processing and then the disposal plans. Those are basically a few things to consider when creating your management plan. First thing, risk control of concrete slurry. There needs to be a control system to protect various runoff related issues. Biggest thing we look for here is the stormwater pollution control, groundwater entries, waterway entries. And the ways to reduce those risks is setting up a proper slurry system that, you could have inlet filters. Inlet filters are filters that can protect anything from going into a storm sewer. You could set up super absorbent booms. Those can help absorb prior to, entering certain areas, and then just setting the whole system up in containment berms. So anything that leaks is actually being staged into a containment berm. Again, analyzing the job site to figure out what's needed is probably the most important thing to do. Containment of slurry. So making sure there's a plan in action to contain the slurry is critical. These methods include properly lined totes. You don't want them to leak unless you have some sort of containment. Properly coated drums, containment berms, bins, outfitted dumpsters with various liners. We see a lot of issues in washout where people use 6 mil liners, but they're designed for brand new dumpsters, and obviously dumpsters being used for various types of things end up with lots of holes in them and they get punctured, then they leak. So then there's slurry systems that are essentially leaking all over the job site, and those typically cause problems. Another thing to consider here too is if you're transporting any of these sort of bins, that it has a UN rating. That's a really big one. A lot of people are selling products that aren't UN rated. So if you were taking solidified concrete down the road, it's important to know that that actually specific bin has a UN rating that's able to be transported legally, and it includes whatever type of substance. It's essentially certified for whatever type of substance could be within that concrete slurry. Methods of collection of concrete slurry. There's lots of ways to take care of it. It really depends if you're indoor or outdoor, but in order to safely and properly move slurry from its source generation to proper containment or your slurry system or processing method, you're going to need some sort of specialized equipment. Typically, slurry vacuums or vacuum tops with various wands or vacuum trucks are typically used. A lot of it is going to depend on if it's indoor or outdoor. One thing to watch too, to make sure, if it is indoor operations, is HEPA required. Again, once slurry becomes dried, there's friable dust that can actually be, produced once it's dry and then vacuumed and then released from the engine. So it's important to know if you're indoor or outdoor and if HEPA is going to be required or not, even if it's strictly designed for wet vacuuming. Slurry processing. So we kind of break it down into 4 options. I'm sure there's more, a lot of creative people in the world. But the contractor first, when setting up the system, must determine what processing system they want to align for the job. So the desired end result of the concrete slurry is uncontaminated solidification. That's the end result. There's many ways to get there, but this is when the slurry passes a paint filter test, as well as other toxicity tests that could be required, depending on your disposal plan. We break it down into 4 different ways. There's multiple ways that you can process concrete slurry. Dehydration. This is essentially achieved by solidification using superabsorbent polymers. Decanting is a hybrid method of essentially using flocculants, pH-reducing flocculants on various materials to actually suspend and separate the concrete and the water, the slurry and the water, so that you can actually pump off the top to an approved drain or reuse it in your process. Filtration is a process where you're actually allowing it to pass through a filter, so you have very, very clean, reusable water for your process, or using filter presses, which are specific machines designed to use pressure. But all processes, any one of these 4 processes, all should recruit pH reduction, because the cake is what's being tested in the end using T-clip. So let's just go through a little bit of slurry processing. Dehydration. Dehydration of concrete slurry is a method of solidification using a proprietary blend of superabsorbent polymers and clay. Clay is the popular choice because it absorbs various metals and contaminants that we know are in concrete slurry versus other superabsorbent polymers that are essentially just designed to absorb free liquid, not high pH liquid. After treating the slurry in a leak-proof container, the slurry should be solidified and be able to pass a paint filter test. So that's the end result using dehydration, simply adding the material and mixing. Second, slurry processing, decanting. Again, decanting is a hybrid method of slurry solidification that includes pumping off the top water of slurry. This process requires treating slurry prior to transferring to a storage bin by using flocculants to separate the slurry from the water, which then the water will be at the top, allowing the water to be easily pumped off, and then solidifying the retenants. What this will do is essentially, concrete slurry is typically 20% solid, 80% water. Some applications could be 50-50, but there's a lot of water within the concrete slurry that can be used from other purposes to reduce that waste stream. Third popular choice, which we prefer, is filtration. So filtration is a method of slurry solidification that uses a bin and spacing device with a filter to separate the concrete slurry and the water. Slurry treated prior to filtering will quickly allow the treated water to flow through the filter, and then the remnants below can be reused or disposed of in an approved drain with permits if required. So the nice part about filtration is there's no sense, you're using gravity and don't need secondary pumps. And also, if done properly with the proper filters, you can actually achieve solidification without using superabsorbent polymers, just specific flocculants. And you can use the filter themselves for the solidification part. So it can be a much more inexpensive option. But again, it depends on the job size and the quantity that you're generating. Filter presses, there's various types of filter press manufacturers. Filter presses are tools that can be used to separate processes from solids and liquids through the use of pressure filtration, where slurry is forcefully dewatered under pressure. These produce cakes. Prior to entering a filter press, the slurry should be processed and pH reduced, just to ensure that the cake itself doesn't have a high pH characteristic. These come in various sizes, from I think small portable all the way up to massive amounts for large road projects. So I'll go through some of the importance of testing. This is, again, I'm speaking from experience here in the United States. I'm sure there's different sorts of regulatory departments and agencies and people that are agencies that regulate concrete slurry, but I'm going to go through the importance of kind of understanding what has been required, what we have seen that's been required here in the United States. So testing your concrete slurry. So after solidification and processing has been finished, the slurry must be disposed of in a proper manner. So that's the first thing to review. There is aggregate recycling plants. There's various types of ways to get rid of concrete slurry. This is really specific to landfills. So landfills are going to typically corporate or large landfill operator, they've been requiring testing prior to accepting solidified slurry to their landfill. Again, most contractors are going to follow what the landfill requires. So you'd have to call your local landfills to see what their requirements are for accepting it. But the testing requirements we've seen, I would say at the highest level of scrutiny to get your concrete slurry to a landfill has included the following: pH testing. Anything over 12.5 pH is considered to be corrosive, which then would fall under that hazardous substance under the EPA, which then essentially could not be handled by any sort of standard carrier, which is kind of a problem. So pH testing is super important to make sure that that pH is not above 12.5 when concrete does have a characteristic to go even above 13. So you really want to watch the pH of that concrete. We see over time too that the pH gets reduced. It starts extremely high and reduces it over time as the concrete cures. So new concrete has a much higher pH than cured concrete. So that's something to consider as well. Second test is toxicity characteristic leaching procedure testing. So this is referred to as a T-clip test. This is very common for landfills to require these tests prior to disposal. But what these tests include essentially is they take the solidified concrete slurry, they introduce rainwater an aspect of over like 20 years or a long extended time. And then they actually manage what leachate is coming out of that cake. So while we talked about that cake, what is actually occurring is it's replicating rainwater in the landfill. So what is going to come out of that, waste if it's rained on? And that's what a T-clip is trying to identify. The EPA and other regulations essentially set parameters, and then anything below those parameters is not considered to be hazardous or special waste. Anything above it is, and then you'd have to, essentially figure out what the process is to handle that waste stream from there. Third testing is the paint filter test, and which is essentially making sure that we have solidified slurry. And the fourth one is sulfur testing. So let's get into pH testing. pH testing is used on job sites to determine proper procedures to handle recycled slurry water. The pH value is determined through testing, very simple tests using litmus strips typically. Practicing and following these measures ensures that the concrete slurry is not a hazardous substance under corrosivity element or clause. The test can be performed in the field with litmus strips. It depends on the operator or where you're disposing it, if it needs to be a certified test or not. Some people do their own testing on pickup. Some require certified testing, but the very simple test that can be performed. It's also good to know that the pH will rise after initial processing. So it's good to test the pH several days after you've actually processed that concrete slurry. T-clip testing, toxicity characteristic leaching procedure, covers a series of both organic and inorganic substances present in liquid, solid, and multifaceted waste that can be considered hazardous or toxic to human or animal life. So this test is performed in a certified lab by a lab technician. This is a very long test. This is complicated. So they're essentially trying to replicate what that waste is going to do in its time living at that landfill. So that's what the T-clip testing involves. Paint filter testing. This is kind of interesting because paint filter and liquid testing is a baseline test for whether semi-solid waste can be disposed of in a solid landfill. This is a test for the presence of leachate or free liquids coming off into the concrete slurry. The reason we test for leachate is that there are any hazardous substances flowing or leaching from the concrete slurry in the landfill. It can potentially affect whether or not those substances in the landfill will generate toxic gases or erode their landfill liners. So this is kind of like step one in any sort of test, is passing a paint filter. One unique thing about the paint filter is it's actually a 5-minute test, and it's a 60 mesh screen. So it's more like a screen on your window more than it is a paper filter. So if you can imagine how dry that needs to be, that's extremely dry. It cannot drip within 5 minutes. So passing a paint filter test is having a very, very, very dry substance. Sulfur testing. So this is an additional test that we've run into. Sulfur test is a requirement of the landfills due to the presence of microbes in municipal waste that can convert sulfur into hydrogen sulfide, which is an odorless, toxic to humans, and yet corrosive gas. This test finds trace amounts of sulfur and sulfide in samples, and the test is performed by a certified lab and technician. So we've seen sulfur tests, and we went through how sulfur can enter concrete, and essentially sulfur in a landfill can create essentially toxic gases. So they're looking for various types of sulfur, and this is the test that you could perform to see if you would be in compliance. So basically, generating your concrete slurry plan could be complicated or not complicated. We're always looking for, what are my requirements and what is the responsibility? So I think responsible contractors, a good thing to start with is to create waste profiles. So if you're working in an auto manufacturing facility, or you're working in a distribution facility or a retail facility, all those different facilities would have a different risk factor. So understanding how to generate waste profiles based off of that could really help you mitigate your risk, and then help establish how much of a deep dive you want to take into, what type of slurry management plan you need to design. It's very important to know that the responsibility of concrete slurry, it falls with the owner, it falls with the generator, which would be the contractor, it falls with the hauler that's transporting it down the road, and it falls with the disposal facility. So once you're generating a waste stream of this type, there's many people that are responsible for the ownership of that concrete slurry, and it starts with the owner of the property. So that's essentially how that works. So not only is it important to do due diligence, as a contractor, but you're protecting the owner, yourself, and everybody down the line if you understanding what type of work environment you're introducing yourself into. So the best thing and way to start is to contact your local regulatory departments that are managing these types of activities, and trying to fully understand what the requirements are. And again, everybody has to take their own risk on how much risk they want to take with that slurry management plan, and what level that plan is going to be detailed to. But there's various references that you can read up on. The CSDA and the IACDS, they have a guide to concrete slurry management. There's great information there. There's also a US EPA concrete washout procedure document. There's very stringent good information in that for best practices. There's concrete slurry. SLURRYMONSTER has a best practices guide. There's also the NPDES, which is the National Pollutant Discharge Elimination System. That is the regulatory department that actually we would be able to submit discharge permits if we wanted to essentially discharge processed concrete slurry clean water or free water into storm sewer drain or something of that nature. There's the Clean Water Act, which is regulated by the United States Code 33. That's the act that actually gets into, U.S. waterways, rivers, storm sewers, anything that leads to them. That's important too to note, is that some storm sewers are connected to sanitary sewer. It depends on your infrastructure. So it's really good to know if your infrastructure has a sanitary sewer and storm sewer shared, or if those storm sewers are going to waterways. That would change the processing ability there. And then the most important document we have in the United States is EPA CFR 40. So that's the protection of the environment. And between concrete slurry, it's been a long time coming of understanding how to process and manage it, because there's different regulations within all these different groups, and it's very hard to decipher what is clear. So essentially, it's based off the interpretation of 5 or 6 different regulatory departments on what is the right thing to do. There's never been anybody that actually is going to tell you the right thing to do. They're just going to give you regulations to comply with, and then you'd have to develop those plans. So I would just like to finish that presentation with all those options, and feel free to reach out or ask any questions if needed. But that's all I have, and thank you very much for listening. And let me know if you have any questions.
Thank you, Ryan. Thank you very much for your interesting presentation. Very, very deep, interesting presentation.
A lot of information.
I would like to invite I would like to invite Erin, if you're there, to turn on also your camera so we can have a little conversation. There you go. So thank you also, Erin, for first for the work you've done to put together the guide about the slurry management and bringing together everyone to do a document that actually can be easy to understand and easy to distribute. In fact, we already have a draft. It's not the final document yet, but we already have a draft available, as you mentioned before. You just click on the links and go to the website. I have a zillion questions for you. I mean, many questions for both of you after the presentation from Ryan. But first, I want to say to the audience, please feel free to share any comments, questions, whatever you want through the chat. So we will be very pleased today that we have Erin and we have Ryan here to share the questions with them. So feel free to use it, anytime. I'm going to start with a question for each one of you. First question is for Ryan. Next question is for Erin. For Ryan, you mentioned quite a number of times the possibility of taking the water out. And what I want to ask you is, how often do you see the contractors reusing the water that has been separated from the slurry to cut again to operations?
Yeah, that's our preferred system. So when we set contractors up with concrete slurry management systems, that is our preferred method. So the whole idea is that you're going to reduce 80% of that waste volume. So let's just say you had 10 dumpsters full of slurry. If you're actually setting up a recycling system, you could get that down to 2 dumpsters of slurry. So there's a substantial savings and cost reduction for setting up recycling systems. And it really depends on how big the job is, how much volume they're producing. We have apps and calculations for contractors to actually understand how much waste they're generating. So once they understand how much waste they're generating, you can simply assign the right system. In most large volume projects, large volume could be just 4,000 to 6,000 gallons. It really depends, down to a couple thousand gallons. But it's very simple to set up a recycling system. And the fact of the matter is, so now you've reduced your waste by 80%. You've also reduced your water requirement by 80%. So once you take your waste stream and recycle the water, we're able to produce 3.5 times the water volume. What that means is, say you started with 1 tote and it was 200 gallons. If we set up a recycling system, we could produce over 600 gallons of actual use water for that contractor. So if you're hauling or storing or managing water like on a truck, it becomes very efficient to set up recycling systems because you don't have to carry as much water. So then you're reducing your water intake and you're reducing your waste generation. So there's a huge amount of savings there. And we're working on carbon credits and different ways to put certifications together to show that.
Okay, thank you very much. You mentioned several times, through your presentation, Ryan, about the U.S. regulations, and you didn't know, about what's going on in other parts of the world. I can tell you that, in general, the regulations are pretty much very similar. What happens is the difference will be on the level of implementation. We have countries like Switzerland or Japan where this is strictly taken care of. And you have other countries where, even though the regulation is rather similar, it's not so different. The level of implementation could be very different. And there's another factor that for us as industry is also very relevant. You mentioned before the importance of knowing a little bit about waste management. And what we found out when it comes to a slurry is that depending if you are looking at it as waste mixed with water and you want to follow the waste management for water, then the regulations are going to be way more complicated than if you take it as a C&D, construction and demolition waste management, which usually is going to be slightly easier, not cheaper, but it's slightly easier when it comes to the testing and the disposal and all of that. So the regulations, to be honest, are not so different. The level of implementation and the route, if your waste flow is water or if your waste flow is C&D, that's where the difference could be. So I don't know if in the US you have the same scenario.
Yeah, we don't have the same scenario. So what it really basically boils down to is, what are you doing with the concrete slurry? So everybody has to ask themselves, where is it going to live, right? You can't throw it in your backyard. So where are you going to take it? There are, I do know concrete slurry, some aggregate processing facilities will take it, and they won't require it because they're already under regulations at that facility. So they'll take liquid or dried slurry. But landfills, so the interesting about SLURRYMONSTER, we have national contracts with all the largest landfill owners in the country. And so all of this started by them regulating us based off of, we manage disposal operations for large contractors. So we're managing that waste stream for them, not only providing them the system to set it up, but also to actually haul and dispose of it to that landfill. We provide all that proper paperwork and testing. So the known fact is that we're actually a service provider and they're requiring us to do it. So in a lot of what we say and we promote is pretty much what we're bound to. So if the landfill if you don't have an option to take concrete slurry and dispose of it anywhere locally but a landfill, then you would have to comply with that landfill's requirement. And they don't care if it's construction or waste. It's really pretty much based off of, you know, what their requirement is to take your waste. So that's how we move forward with the concrete slurry management. It's based off of where is it going to end up at and where is it being disposed of.
Did you approach like ready mix plants or precast concrete plants that actually could use some of this slurry that is somehow wet or this material that actually has a lot of cement? Did you approach them so this could become part of a circular economy workflow?
We thought about that. Here's the interesting thing. So concrete slurry that becomes dry without being processed essentially now is silica dust. That is a very high risk to have an issue. So if you do have a processing system, whether you're using solidification, superabsorbent polymers, or flocculants, or various types of things, the bottom line is can the plant use it? What are those agents doing to that actual slurry? Because you've changed the composition of it, right? Now it's just not sands, it's something different. So until we have a full fundamental understanding of the composition of the cakes now that they're being processed, we need to understand that first before we offer them to different types of industries.
Yeah, understand.
Right, because I don't think super absorbent polymers would be a good thing to have in concrete.
Well, you know, that's a tricky one. Actually, my questions are also related to that. Also now to Erin, to a more practical perspective. You know, as you said, Ryan, the rules and regulations are more or less clear. They could change a little bit depending on the state, depending on the country where you live.
Yeah.
But you know, when it comes down to numbers, Ryan, go ahead.
One more thing is the landfills actually, although they are very strict on how we can get the slurry to them, they love it because we're giving them a free landfill liner. because all the flocculants in processed slurry, right, is creating a free landfill liner because, you know, during the process, you're introducing various types of flocculants and solidification products. So then once that's introduced to the landfill, that's in their landfill. So anything that passes above it through it essentially is acting like a minor landfill filter. So
that's good.
Kudos to them.
Yeah, that's good. That's good. So I was saying a couple of practical questions to you, Erin. You know, Ryan said before, rules and regulations could change a little bit, but rather similar in all of the states in the U.S. But when it comes to the customer, you know, is the customer willing to pay the extra work that it takes, you know, to handle all of that properly? Even though it is our regulation, we would probably have contractors that try to do the right thing and contractors that maybe look to the other side. So, you know, it creates a situation of tension there. So what do you think about this? I mean, without embarrassing anybody, but what is your view when it comes to the market, Erin?
Well, I think, like you said, it really varies on, and again, this is a big variation by state. You know, California, for example, has very strict regulations for anything that has environmental impact, including slurry. Other states, you know, for example, Florida, where we live, to the best of my knowledge, not a whole lot of regulations. So, you know, there's kind of the, I guess we'll call it maybe the moral responsibility. And, you know, as a contractor, do you want to do, you know, something where you are, you know, being seen as protecting the environment, even if it costs you a little bit more money? And that is the debate. And that's why, you know, any product that can be useful to help treat the slurry, you know, make it less harmful to the environment and dispose of it properly, even if that doesn't necessarily, sometimes you're going above and beyond local regulations, and we see it in many cases. I believe one of our members actually just finished construction or is close to finishing construction on their own slurry recycling plant. So they have built a plant at their company headquarters. They're going above and beyond what they need to do. And I think that's great, and I think some of our larger companies, our larger contractors certainly can afford to do that. But there are certainly going to be some smaller companies in different areas of the US, and I'm sure internationally as well, that maybe don't have those resources. So for them, it's not if they don't have to do it, they're probably not going to. But that's where the more avenues that we can provide our members, partnerships with Lorraine's company and several other members that we have that offer similar services are great, because then we're giving them an option, and maybe making it easier for them to at the very least abide by local and national regulations, if not do something where they feel like they're not doing harm to the environment.
I could comment on that too. That's
Sure, that's
fantastic, Erin. We've solved this problem by giving the contractors tools and processes to make them more efficient. So we don't approach the concrete slurry management from the environmental perspective 100%. So the bottom line is, when you wet cut anything, it becomes a much more efficient, productive process. So they're already gaining, reducing labor at that point. So what we've done is we actually design equipment such as propane slurry vacs and propane processing slurry machines and all these various types of solutions that the contractors are gaining efficiencies. So once they gain efficiencies, then it's like, for perfect example is, sludging up tanks. So if you pick up slurry in various tanks, you sludge them up. Well, if you use our high pH reducing flocculant, guess what? You're never going to sludge up a tank again. So we set it up in a way where we're providing very efficient solutions for the contractors, and they don't look at it as an extra cost, but we get them all the way up to being compliant. And then it's their decision of what do they want to do with that waste, and that's where the decision needs to be made at that point, because they've already processed that waste to encapsulate all the metals, absorb various contaminants, do pH reduction. They have the waste prepared in their process. And then the only decision they have to make is, where am I taking it, or where am I putting it, or who's responsible for it?
Yeah. Actually, both of you mentioned something that we are, of course, very concerned, which is liability. I remember a couple of years ago, we did a study tour to Japan, and we saw some of the market leaders over there that they had their own facilities to recycle the slurry and so on. And this is something that in Europe, very concerned about, because you would be mixing waste that is coming from different sources, and when you mix it, then you become the producer, and this is a liability that not everybody is willing to take, especially depending on the rules and regulations that you might have on your local area, maybe not even in the state, but on your local area. So this is a tricky thing. When you mentioned that, Ryan, I really advise everybody to please look at your local regulations, look at your waste flow and so on. And this is going, traditionally, concrete cutting companies were just basically handling the concrete, which was very easy to transfer to a waste management or a recycling facility. But this is just, as you mentioned before, on the testing and all of that, this is going into another completely different field. So we advise that do your math, do your numbers, and then, of course, as Erin mentioned before, be very careful to handle it properly, because you might have liabilities, and you might want to do the right thing, even if you're not mandated by their institutions.
That's an excellent thing there, because we actually ran into this, because we're actually promoting the contractors. We're like, how is a contractor going to test a cubic yard of slurry in every project? It just doesn't make sense, right? It's a very small amount. So the response we have in the US is the same thing. Every specific location where that came from is actually a specific generator. So you can't mix them. You only have to take like one test per job site or whatever they're, some are requiring if you're testing it all. But the waste profile is specific to the location. Yeah. So you can't combine waste, or you're going to have a whole new problem.
Yeah, we are familiar with concrete cutting contractors cutting a bridge, which, if it is a road bridge, it's going to have lead from the gasoline, it's normal, mercury from the catalyzers, it's going to have all kind of hazardous substances. So you want to be very careful not to mix that with another thing. And this is another question for Erin. Did you consider the possibility of doing some kind of guidance document when it comes to waste management to the concrete cutting contractors, especially to SMEs, small and medium-sized companies that maybe, before they do the operation, that hey, I have to inform my customer, you are the producers, I'm willing to take, the waste management for you, but at any point you are going to be responsible for that? Or is this something that is not really needed or you didn't consider from CSDA?
I certainly wouldn't say it's not needed, and it's it's kind of an ongoing conversation. And I think as regulations change and as you go to different parts of the country, the conversation becomes different. We also produced a what we call a best practice document on the same topic, managing concrete slurry. Obviously, a little bit more focused on the U.S. Especially some of our smaller contractors, I think, there is some hesitancy to take responsibility for something if you don't have to. The liability always is a big concern. So it's difficult. There's no one size fits all guide that we could do because there's so many factors that go into it. There's certainly conversations that we have on a regular basis. And we've hosted convention roundtables on the topic. We've had presentations at our annual convention on the topic as well. And it's, again, led to the creation of some of these documents. And with the latest OSHA regulations, that were launched in 2016 and continue to evolve. And I think you'll hear some of our contractors say that during COVID over the last 2 years, those regulations from OSHA haven't been enforced as much. We may see that changing again coming up soon, but we are trying to work with OSHA to, kind of stay ahead of that. So it's certainly something that is always on the table for discussion. It's just a matter of figuring out, what is the correct answer to that question, and what is the best approach for an association who represents many different types of contractors, sizes, services, locations, to do that. Is that something that we can do easily? The answer is probably no, but is it something that we are certainly always working on and paying attention to? Yes, we certainly are.
Thank you. Very good answers. Thank you very much, Erin. Thank you both for your availability, for sharing your knowledge, and for your time for this. It's now almost 4 o'clock here in Europe. I believe it's 10 o'clock in the US, at least on the East Coast where you are. I don't know for you, Ryan, what time is it there?
10 o'clock.
Okay. Oh, there you go. So
yeah,
any final remarks, any final comments from your side before we finish this webinar?
No, anybody could reach out to me for, any questions at any point in time for anything, really. So if anybody wants more information, and we'll be happy to do that. We're going to update the presentation too, to put some of those references, where people can go and read upon themselves some of the details that we discussed in the presentation.
Perfect. Thank you. Erin, from your side, any final comments or remarks?
No, just this has been great. Thanks, Ryan. Very informative. Glad that we are able to kind of partner with this, tie it into our slurry management guide. I think it's obviously a very important hot topic that a lot of people have a lot of interest in. So I think all of us continuing to having these types of conversations, learning more about what we can do and how we can improve this process is only going to make the industry better.
Perfect. Thank you. Thank you very much, both. To our audience, thank you for being there, for being available. We will send you a survey by email. You are also seeing it now on the chat. It's important for us that you give us your feedback to improve. Once again, thank you. All the best to everybody, and see you in the next webinar.
Thank you.
Thank you.